Good morning, everyone. This is Mr. Peter, and in today's chemistry class, we'll be talking about the electronic configuration, which is basically the way electrons are arranged in an atom. And this is determined by the order in which the subshells occur on the scale of increasing energy levels. So I will discuss subshells, energy levels, and in passing, we'll also talk about the 4 quantum numbers. Look at the 4 quantum numbers, and also we'll talk about principles or rules that govern electrons filling into orbitals. So welcome again to today's chemistry class, and the topic is electronic configuration, which is the way electrons fill into the orbitals. Thank you. All right, so let's begin. Now, it was Niels Bohr who stated that electrons orbit the nucleus in specific energy shells or levels. Remember from yesterday, we talked about the historical development of the atomic structure, and Niels Bohr proposed the planetary model. Okay, he said that electrons orbit the nucleus, like planets orbit the sun, orbit the nucleus in specific energy shells or levels. Okay, so let's go to the electronic configuration now. Okay, talking electronic configuration. Let's look at this for hydrogen. Now this is the orbital diagram. We call this the orbital diagram. Now this is 1s. That's the first energy level, 1. 2 is for the second energy level. So this is also second energy level. So for hydrogen that has just one electron, it fills into the first energy level and the first s orbital there. Okay. Helium has atomic number of 2. That's just 2 electrons. So go 1 1. Now, okay, so like I was saying, this is the electronic configuration for hydrogen, 1s1. While this diagram is called the orbital diagram, it is a picture of how the electrons are filling in. So look at for helium. Helium has the electronic configuration of 1s2. Okay, and this is the orbital diagram. So these are the orbits. Now, do you observe that the 2 electrons are facing different directions? This brings us to one of the principles called the Pauli Exclusion Principle. This states that no 2 electrons in the same atom have the same 4 quantum numbers. Basically, just saying that they must behave differently, but at least spinning in different. Right. So I was saying that the electrons are facing different directions. So this brings us to Pauli Exclusion Principle. The Pauli Exclusion Principle is one of the 3 principles that govern how electrons fill into orbitals. So it's basically saying that no 2 electrons in the same atom have the same 4 quantum numbers. We'll talk about the 4 quantum numbers later, but it's just saying that they must behave differently by at least spinning in opposite directions. Okay, so no 2 electrons can be in the same direction. So this is facing up and this is facing down. Okay, so that's Pauli Exclusion Principle. They must behave differently. Okay, so note that principle. Let's continue. So you see the first energy level, that's 1, because 1 is for the first energy level or the first shell. Energy level and shell are synonyms. So 1 consider as 1s. So the 1 is saying that is the first energy level. So the first energy level is filled. So here for lithium, which has an electronic configuration of 1s2 2s1, this is lithium's orbital diagram. So like I said, electronic configuration orbital diagram. So see, 1s has to be filled before 2s. So the first energy level has to be filled before the second energy level. So 1 is filled before 2. Okay, this brings us to another principle. We'll call that the Aufbau Principle. Okay, so basically the Aufbau Principle states that electrons enter into orbitals in order of increasing energy. The Aufbau's principle states that electrons enter into orbitals in order of increasing energy. Okay, so look at, we have the 1s is filled first. The 1s is filled before we come to the 2s level, energy level. Okay, so it goes on. So by the time that this energy level is filled before we come here like that, so it goes on like that. Okay, so that's how. So 1s is filled before the first 1 is filled before 2, like that. All right, so now this this is the Aufbau diagram. This diagram helps us to see how the how the electrons fit into the energy level. So when you draw this, so 1 stands for the n equals to 1, that's the first energy level. 2 is for the second energy level. 3 is the third energy level. So this arrow says 1s. The 1s orbital will be filled before the 2s. After 2s, the electrons go into 2p before 3s. So 3p before 4s, 3d, like that. So this is the Aufbau chart, which explains the Aufbau principle, which simply states. All right, guys, let's continue. For the first 20 elements, so we're looking at boron. Look at the electronic configuration of boron: 1s2, 2s2, 2p1. Okay, and nitrogen like that. So just look at the orbital diagram. You see, we have 1 electron, 1 1 1. Well, you would be thinking that why are you sharing it like this? Why don't you just enter 2 here? But it's 1 1 1. It's saying that. So this brings us to the third principle. It's called the Hund rule. Hund's rule states that electrons are distributed in the same subshell singly, that is 1 by 1, 1 1, before pairing occurs. Okay, so I repeat Hund's rule. So Hund's rule states that electrons are distributed in the same subshell singly, that's 1 by 1, before pairing occurs. Pairing means doubling up. Okay, so you see the nitrogen orbital diagram. So you see the electrons in the same subshell. This is the 2p subshell. It goes into 1 by 1 before it starts to double or pair up. This is pairing, before pairing occurs. Okay, pairing, and of course they are facing different directions. Electrons are spinning differently. One is going up, the other one is spinning down. Of course, that is Pauli's exclusion principle. We said that they must behave differently by spinning in opposite direction.